Okay, so today we're going to talk about the arithmetic sequence. All right, so let's review. It says determine the common difference between each term. So remember, the common difference is what you're adding or subtracting to go from one term to the next. Sometimes you'll be able to tell right away. So to go from 6 to 8, we're adding 2. Add 2. 8 to 10 is an add 2. 10 to 12 is an add of 2. So that means my common difference D is equal to positive 2. All right, so I want to see what am I doing to go from negative 3 to negative 7 to negative 11. So what you want to do is, if you have a hard time figuring it out, is take two consecutive terms, negative 7 and negative 3, and you want to subtract them. But take the second term, the one that's behind it, which in this case is negative 7, and minus the one that's in front, in this case, which is negative 3. So negative 7 minus a negative 3 is negative 4. So the common difference is negative 4. Okay, so let's talk about what an arithmetic sequence is. The arithmetic sequence is the difference between consecutive terms is constant. The common difference D. So there is a formula to come up with the formula to come up with each one of these terms. And this is the formula here. It's a sub n equals a sub 1 plus n minus 1 times the common difference. So a sub 1, remember, is the first term because it's a sub 1. N would be the nth term. And D is the common difference. Okay, so let's take a look at the first example. It says, if a sub 1 is equal to negative 1 and a sub 2 is equal to 1, determine the equation used to find the nth n term and state the common difference. All right, so I want to use this formula, a sub n equals a sub 1 plus n minus 1 times the common difference. So you have to find the common difference. So I know in my sequence so far, I have negative 1, comma 1, right? That's the first term, second term. So to come up with the common difference, what are we adding or subtracting by to go from negative 1 to 1? If you're not sure, do 1 minus negative 1, which is 2. So 2 is my common difference. So I have a sub n equals a sub 1. A sub 1 is negative 1 plus n minus 1 times the common difference is 2. Now, if it asks for the equation, you could leave it like that. I'm just going to erase this over here. You could leave it like that. You wouldn't see it written like this if it was in multiple choice. So I'm just going to move this up a little bit. I'm going to simplify this. So this would be a sub n equals negative 1, distribute the 2. So I get plus 2n minus 2. So here's my formula, 2n minus 3. Now if I ask, what is the 25th term? So instead of me taking negative 1, 1, and start writing down all the way up to the 25th term, or even if I asked you the 50th term, you don't want to sit there and write out all 50 terms. So we would want to use the formula. To find the 25th term would be a sub 25, which is 2 times 25 minus 3. So 2 times 25 is 50, minus 3 would be 47. That would be how you would find a specific term. Okay, so let's take a look at these problems down here. Okay, so Naomi is selling tickets to a school play. An adult ticket is $6.50 and a student ticket is $4. Naomi sells X adult tickets. So we don't know how many she sells. And 12 student tickets. Write a function f of x to represent how much money Naomi collected from selling tickets. All right, so this is what we know. She sold 12 tickets and each ticket for students is $4. So I have 12 times 4 is $48. That's how much she got from students. An adult ticket, she sold X adult tickets. So that's X times, well, 650. So that's 650X. We want to know, write a function f of x to represent how much money she collected. So to represent how much money she collected, I would have to add the adult tickets, right? Adult plus student. So f of x is equal to the adult tickets with 6.5x plus the student tickets, which is 48. All right, and the last one down here. Okay, this is actually from a Regents. It's from an algebra Regents. All right, in 2013, the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce and 20 cents per ounce for each additional ounce. Which function would determine the cost in dollars, C of z, of mailing a letter weighing z ounces, where z is an integer greater than 1? All right, so no matter what, to mail a letter, it's going to cost 46 cents up to 1 ounce. And then I have to start paying more if it's more than an ounce. And if it's more than an ounce, it's 20 cents per additional ounce. So we can cross off 1 and we can cross off 2. And the reason why we could cross them off, because this is 46 cents times the ounce. It's not 46 cents an ounce. It's 46 cents up to 1 ounce, which means no matter what, it's going to cost 46 cents. And the same thing with this. So here's the ones that have 46 cents no matter what. Now it's 20 cents per additional ounce. Well, it's an additional ounce past 1 ounce. So you have to take your ounces, which is z, and subtract the 1 ounce you're paying 46 cents for. So that would be this one right here, and then pay 20 cents per ounce. So it's 20 cents times the number of ounces minus 1, because I'm already paying 46 cents for that one particular ounce. So it is choice 4. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.